Okay, example 31 about constructing shear moment diagrams. Construct the shear and moment diagrams or the beam loaded as shown below. Also construct the elastic curve. So we have here a beam with an interior hinge here. So there are two unknowns here, 2, 1, 1, so 6, and there are two free body diagrams. So 6 equals 2 times 3 times 3 times 2. There are three equations per free body diagram. So there are two free body diagrams, so times 2, 6 also. So considering AB, let's call this vertical reaction at A to B sub A. Then shear just to the left of B, which is equal to shear just to the right of B. Then R sub C, then R sub D. So considering AB, summation moment about B equals 0, clockwise positive. So we have V sub A times 4.5 minus 80 times 2.5 equals 0. So V sub A is 44.444 kilonewtons upward. So likewise, summation moment about A equals 0, counterclockwise positive. So V sub B left times 4.5 minus 80 times 2 equals 0. So V sub D left equals 35.556 kilonewtons. Then considering BCD, so of course HA is the horizontal component is not important in the shear and moment diagram construction. So summation moment about D, considering this portion BCD here, clockwise positive, so we have R sub C times 6, then minus 35.556 V sub B right and V sub B left equal, so times 9. Then the vertical component of reaction of 100 is 100 times 4 over 5, and the moment arm is 7.5. Then minus 20 times 4 times 4 minus 60 times 1 equals 0. So R sub C is equal to 216.667 kilonewtons. Then summation moment about C equals 0, counterclockwise positive. So we have R sub D times 6 plus 35.556 times 3 plus vertical component 100 times 4 over 5 times 1.5. Then minus 20 times 4 times 2 minus 60 times 5 equals 0. So solving for R sub D equals 38.889 kilonewtons. So we are now ready to sketch the shear diagram and the moment diagram. So this is the shear diagram in kilonewtons, moment diagram in kilonewton meter. So first we go up 44.44. That's 44.44. Then between A and this load, no, so constant 44.444 minus 80 is negative 35.556, which is the shear here, constant. Then 0 or continue only because that's internal. So 35.556, then minus 100 times 4 over 5 going down. So that's negative 115.556. Then between these two, there's no load, so constant. Then plus R sub C, which is 216.667, so it will rise to 101.111. Then minus 20 times 4 minus 80. So we have 21.111. Then between these two, there's no load, so constant. Then minus 60, negative 38.889, then uniform, constant, then RD is 38.89, so that closes the diagram. So that's the shear diagram. For the moment diagram, so moment at A is 0 because that's a pin and that's the end. So area is 44.444 times 2, so 88.888, then minus 35.556 times 2.5, it is expected that the moment about the hinge is 0, so this should be 0. Then minus 35.556 times 1.5, it will go down to negative 53.334. Then area of this is negative 115.556 times 1.5, so negative 53.334 minus 115.556 times 1.5 is negative 226.668, and plus the area of the trapezoid, you can easily compute that. 1/2 of quantity 101.111 plus 21.111 times 4, then add it to negative 226.668. So area 1 is 1/2 of 101.111 plus 21.111 times 4, so that would be 244.444 plus negative 226.668. That's positive decreasing, so the curve will look like that, and the result here is positive. So this is not a straight line, this is a curve, and it is equal to 17.776. Then from here to here, plus 21.111 times 1, so it rises to 38.887, then minus 38.889 times 1, so there's a difference of negative 0.002, but that is considered 0, practically 0. So that's the moment diagram. Now here comes the elastic curve. So we have to locate this zero moment, which are here. So project upward. So for this portion, it is concave up like that. Then here, concave down from this portion up to 0 moment. Then from here, concave up again because the moment is positive. And we have points of inflection, the hinge, and this point here. So that's the moment diagram and the elastic curve, of course.